So thank you all for joining the Salt Basins TIG webinar today. Our presenter is Isaac Odeh. He is a PhD researcher at the Basins Research Group, Imperial College London. He has interest in deep water systems and salt tectonics, and has worked on channel systems in Deepwater New Zealand, that's the Taranaki Basin, and the Central North Sea. So thank you so much, Isaac, for being here. You can go ahead and share your slides.
All right, thank you, Clara. Good afternoon, everyone. If you're from the UK, I don't know where, Clara, what time is it in Mexico? Thanks, AAPG Salt TIG Group for the privilege to present a webinar. I'm part of the work I've done during my PhD. Today, I will be giving a presentation on segmentations around active salt diapers in the Central North Sea. Yeah, so salt tectonics. I think over the years we've seen an increase in interest in trying to understand salt tectonics, especially with the fact that there's been a huge interest in deepwater explorations and in so many passive margins of the world that are characterized by salt tectonics, i.e. the West African margins, the offshore Brazil, the Gulf of Mexico, and some part of the Caspian Sea. And that had actually sort of propelled our over-increasing interest in trying to understand how these enigmatic structures actually control your typical deepwater petroleum systems, especially the reservoir and trapping mechanisms. So when you talk salt tectonics, you sort of tend to look at deepwater channels and how these structures interact with deepwater channels, and what are the implications of those sedimentary systems that were controlled by salt tectonics when it comes to petroleum exploration or an exploitation. So in today's talk, we'll be looking at a typical deepwater systems and how various salt structures that we see in deepwater systems interact with those deepwater processes. So it's more or less an established fact that salt diapers often control and influence deepwater processes. And usually the interactions results in complex stratigraphic architecture, i.e., affecting reservoir communication, reservoir compartmentalization, and sort of a variable facies distribution around those salt diapers. We, in this talk, we'll aim to understand how salt diaperism influence deepwater sedimentary processes and how they sort of control reservoir quality around the salt diapers. Our study will be taken from the Central North Sea, located offshore Aberdeen, and the data set we'll have is covering approximately 1,250 kilometers square and covers part of the quadrant 22 and 23. I'll be using a 3D seismic data set, which is time migrated, with a very decent resolution. I used to say high resolution, but Chris would be like, is it really high resolution? So I'll use the word a decent resolution. At least is well enough for us to image certain structures of interest. And I have 15 wells given to me. So quadrant 22 and 23 actually covers part of Meganza Scooter and Meganza Scooter fields. And I have a couple of cores as well to sort of show us how this lithologists look in cores and what are we able to see to sort of decipher the fact that the structures actually control these systems from the cores. And our interval of interest is going to be the Forties, which is the Upper Palaeocene depositional systems. That's the old Sele units, and stratigraphically overlies the Sele Formation, which is predominantly hemipelagic shales. And yeah, the Forties fan has some sort of an extensive depositional fairways, and there are quite a few studies that sort of document a two provenance source of the Forties. There are the lateral or the Garnet source Forties fan, and there is axial or the more Nelson sourced Forties fan system. And of course, it's been proven that the dominant source of the Forties fan actually are sourced from the axial fairways, and they continue down southeast to the piers and sort of terminate against the Norwegian anyway. I think there is an equivalent of the Forties in the Norwegian graben. So here is a regional seismic line to give us some sort of a conceptual idea of what the study interest or the study area looks like. You will see the Meganza diapar, the Marker diapar, and the Scooter diapar. And of all the diapars we've captured in our study location, the Scooter diapar actually is sort of I will say, buried at the time of the Forties deposition, even though there are the structural imprints created by the diapar, which are sort of conformed by the younger stratigraphy. So I guess the Cretaceous chalk sort of arrested the Scooter diapar growth. So we only have the Makar, the Meganza, the piers further down southeast, the Marian diapars, the typical diapars that pierce through the Forties formations. So you see that the Meganza and the Makar pair the Forties sandstone. We sort of observe a similar relationship between the Makar and Marian as well, which are not really part of the study, but for a more conceptualized understanding of what the diapars are doing, we sort of look at similar diapars that shows similar reactions or interactions with this depositional system. In this case, the Scooter doesn't pierce the Forties, hence being arrested during the Cretaceous period. Yeah. Right. So this a typical seismic line taken across the Scooter diapar, and you will see that Scooter ceased to exist at the Cretaceous level, and every other stratigraphy younger than the Cretaceous sort of conform to the abdomen structure created by the Scooter diapar. So here are seismic attribute maps that are extracted from P4, that's the base Forties, and P6, the top Forties, sort of to have an idea of the depositional fairways and how these structures we are sort of interacting with these systems. And on the attribute maps, you could see that the bright amplitude, which we pick out to represent the fan lobes and the sheet sands, they were routed into the basin. Unfortunately, at this part of the basin, we didn't get to see more of the channels because you only get to see the channels around the Forties Montrose High. That's where the fan, the Forties fan is more channelized. But as you come down to the Meganza PS area, the Forties fan is more lobed and more sheet in nature. So we didn't really get to see more of the channelized kind of a typical geomorphology you would have seen with channel systems. But again, we drew our sort of insight from the high amplitude reflectivity and their distribution around the salt diapars to infer that actually you could see that some of those bright amplitudes are sort of diverging away from these diapars. You could see a bit of a ponding in between those diapars, you know, so, and that's beginning to give us a clue that actually from just a geomorphology point of view, we could sort of easily decipher the fact that a lot of these diapars sort of standing on the pathway of these deep water systems act in such a way that whenever the systems are flowing into the basin, they sort of try to avoid any obstructions on their path, in this case, a salt diapar. So you tend to find the lobes flowing away from the diapars and probably taking advantage of the depositional lobe created between the two diapars, sort of deposit some of the sands. And you will notice which is very typical of what the mini basin will look like, a more brighter amplitude reflections in between these two diapars. Well, an argument arose during my viva. I was telling Clara a while ago about Matt saying whether these are actually mini basins or they are just salt saddles, which in this case would imply that these are just fluctuating sea levels interacting with the sediment deposition into the basin, and not your typical deposit created waiting for sediments to be deposited. So this like a more extensive interpretation of what we see happening on the attribute maps. But again, for us to understand the characteristics of this Forties on seismic and actually understand how this characteristics varies around the salt diapers. I'll be taking a couple of seismic lines for us to actually see on cross sections what actually these faults look like and what's actually happening around the salt diapers. Are we seeing those actually bright amplitude on seismic cross sections? Are we seeing any thickness increase or decrease? Are we seeing any dragging up of the unit as the diapers sort of try to pierce? Do we sort of see some sort of a same tectonic interaction or association or relationship with them? So to start with, you will see seismic line A, which is taken at the crest of the Merganser diaper. Mind you, the Merganser diaper actually continued up until the Pleistocene. Yeah, up until the Pleistocene. So it was just a line taken, not really representing top Merganser, but something that was arbitrarily taken to represent across the Merganser diaper. And what you will see here is, you will see this your typical Forties interval that was taken, and how the units were sort of thickening away from the Forties and thinning as the Forties go. So this is not an entire extent of the Forties, but we have an idea that actually the Forties, as is piercing through, is dragging the unit upward, you know, and the system was thickening away from the Forties sandstone. And you could see the seismic variability, you know, some chaotic nature, which are not explicitly showed on the seismic line, would represent your typical sort of a slumping, something that was dragged upward and slopped down into the basin. As compared to the last seismic line I showed, which was a scooter one, we didn't really get to see that dragging effect, but more of an abdomen structure created by the scooter. But then the sedimentary unit sort of conformed to that topographic kind of expression created by the scooter diaper. So what we see here is you could see those bright amplitude reflection packages are characterizing the Forties, similar to what you see on the attribute maps. That you also notice the thinning towards unfolding of the Forties against the Merganser diaper. Images are poor due to steep dips and overhanging of diaper head. Again, seismic line B was taken in between the scooter and the Merganser diaper. What I initially interpreted as mini basins, and what we see here is you see this fairly thick Forties unit and sort of a high amplitude reflectivity that is sort of subparallel and continue all through, maintaining more or less kind of a uniform thickness all through. So, and unlike around the diapers where they're either thinning and thickening away, here you tend to see a more of a uniform kind of a thickness. That might probably implies that there was sort of a depot center created and the Forties routed around those two diapers, the scooter and Merganser in this case, and sort of routed. And we're seeing a bit of a chaotic reflectivity in between this unit. Could they represent those units that were sort of slumped on the flank of those two diapers, which in this case, we thought they actually represent those sort of a slump units, your debris or your MTCs that will go further to sort of have a look on the core facies that we analyze. So what we saw here is a gentle thinning towards the southwest and variable reflectivity within the Forties. You know, your bright amplitude we interpreted to be your kind of a massive sandstones, you know, and some bit of a chaotic will represent a bit of the muddy, or some heterolithics that were integrated with the Forties sands. And if you go down, what you're seeing is more of the Lister shales, so which we know is been overlain by the Forties sandstone. This is a seismic line taken across the scooter. A very similar relationship to where you find thinning at the crest of the scooter and thickening away from the crest of the scooter. But in this case, there were no dragging effects. Yes, on a variance attribute map, you will see your typical rate of faults, which isn't well manifested, given that this very salt diaper has been arrested right from the Cretaceous, and we're looking at the Paleocene. So I think the much more older stratigraphy showed more imprints of radial faulting than do the Paleocene. But even at that, we could still see a bit of a displacement of faults around here, showing your typical radial faults on the crest of the scooter diaper. And you notice this thickening away of the diapers of the Forties away from the scooters. So then we saw that the Forties thin on the crest of the scooter, the thickness increases away from the crest towards the flank of the diaper, which is a very similar relationship that we saw with the Merganser salt diapir as well. And this is like a more regional line that was taken across Scuta and the Merganser, just for us to actually understand what's actually happening as we move away from the Scuta down to the Merganser. And what we saw basically, it's like a combination of the two case studies we had looked at already. What does it look like on the crest of the Scuta? What does it look like on the crest of the Merganser? And here you're seeing this, a thinning abdomen, a more thickening, a thinning on the flank of the Merganser. Similar relationship here happened. I had a seismic line, which unfortunately I didn't include. You will actually notice some sort of a relative kind of a positioning of the Forties packages, which sort of maybe implies uneven movement of the Forties or the diapir itself. So you will find that on another side of the Merganser flank, the Forties appear to be higher up, and on the other side of the Merganser, the Forties appear to be more downward. So that would probably indicate some sort of a rotational effect of the Merganser diapir as against the stratigraphy itself. And this is what I was initially thinking is your typical mini basins, but I guess if you look at your, say your passive margin, you Gulf of Mexico, offshore Angola, you will see a problem with a much more well-developed mini basin. So there is this, either is a mini basin or it's salt saddles, and well, this is actually what I'm trying to sort of fix as part of my corrections. So then what do we see? We saw that the Forties thin onto the flank of the Merganser. We actually noticed this drag upward as the diapir moves around the Merganser. We saw that the thickness increases away from the crest and towards the flanks of the diapir. And we actually noticed this sort of a chaotic reflectivity around this interdiapir space, so in between the Merganser and the Scuta diapir. So so now what is our key observations? What we actually observe is on the RMS Amplitude Map, we sort of confirm the fact that the Forties maintain a typical northwest-southeast powder flow direction for the Forties flank system. So being sourced from the Forties Montrose High down to the Pierce area and down to the Norwegian Graben. We also notice that the top and the base Forties flank system is characterized by subparallel high amplitude reflectivity, and that internally the Forties flank systems are characterized by variable amplitude reflectivity, where you will find some chaotic reflectivity, some low amplitude reflectivity, and some bright amplitude reflectivity. And in this case, most of the chaotic, we sort of interpret them to be either debrites, and most of the high amplitude reflectivity are small, massive sandstones. And where you have those, the variable reflectivity could maybe indicate heterolithics in this case. And around the diapir flanks, we noticed this low amplitude reflection packages, which we thought would represent the deformed hemipelagic mudstones or slump deposit, whereas those high amplitude reflectivity could represent the sandwich units. So the Forties flank system appears to thin towards the diapir flanks and the crest, and thicken away from the crest and the flanks of those diapirs. So because I had access to well as part of the study, some of the wells we had, we sort of, I sort of adopt the shell correlation well formation tops, your typical T75, T70, T65, sort of correlate across my study location. So this is a correlation done on the Merganser wells, and you can see how the thickness sort of enormously varies, and how you just move away from a well that is 350 meters away, you know, to say a well that is 877 meters away, and the thickness just, even though they tend to sort of maintain a certain uniform thickness, but you could see some places like in between MG1 and S1 and S2, this thickness, highly thick Forties that was sort of preserved. And these wells actually were located somewhat around the mini basins. So the problem is, because the wells were largely sidetracked, trying to sort of pinpoint the exact location of the wells become difficult and patrol. And one of the things that I chased Shell to sort of get was if I could have access to some sort of control well, probably a well away from the crest, from the diapir province, where I could sort of see if I can correlate away from the diapir what this unit looks like, but unfortunately I couldn't have access to them. So I was more or less forced to work with the wells that I had. And the wells that I had were largely sidetracks. And that's why you could see 14Y, 14Z, which is a sidetrack wells. You have this MGA, MGB, which actually is sidetrack of this well. This is a sidetrack of this well. And then this is a sidetrack of this well. So they are all more like a single well that was drilled and then sidetrack away because of the diaphragm to sort of understand what the stratigraphy looks like around the diaphragm. And our correlation sort of proved that actually this variable thickness distribution and even the facies around the salt would have shown to us that actually this salt diaphragm is in many ways controlling the systems in terms of where they are deposited, how the facies are laid, and how the thickness would vary along the line. So in just moving from here to here, you would have seen how the thickness really varied around the line. So you're moving from maybe the wells that was here wasn't really too thick because it's more or less on the flanks of the diaphragm. As you move away, you saw this thickness changing so massive and then thinning again. So this is sort of giving us an idea that actually salt diaphragms are just standing there, not as just structures, but their control on the system is huge. And really being very exact on trying to understand how this thickness vary becomes a challenge because first of all, you need to understand what's the exact position of the salt. Like the Berganza diaphragm, this is what seismic is telling me, but I remember laying my hands on the paper and actually showing the real geometry of the seismic to be much more smaller than this. And so that presents a challenge to exploration teams trying to know what is the extent of this diaphragm and how can we sort of extrapolate in trying to understand what the stratigraphy will be around this diaphragm. So this is another well correlation taken on the Scooter diaphragm. And you will notice that because this well were largely drilled on the crest of the diaphragm, there is more or less a uniform thickness because we didn't get to have an idea of what it would be like if we had moved away from the Scooter because there is no control wells. All the wells we had were just on the crest. And then we tend to see almost a uniform thickness, even though there is still a bit of a variability in the thickness on the crest because it's not entirely on the crest. You will see like this well is trying to move towards the flanks. This well is more or less moving towards the flank. So they are a bit thinner than you will find some wells that are on the crest. Basically, what I'm trying to sort of emphasize here is the fact that on the crest of this diaphragm, we're seeing more of a uniform thickness. If we had wells, say they were located around this area, and around this area, we would have actually seen this enormously thicker units as you go away from the crest of this Scooter diaphragm. So I also have access to core data sets to sort of see kind of a petrographic understanding of how this Forties looks like around this diaphragm. And I sort of classified the core into facies so I could sort of conceptualize what the rock looks like and how they sort of relate to each other around this diaphragm. And one of the facies I had was the amalgamated sandstone facies, which comprises of the massive sandstones that are predominantly structureless and the massive sandstones that showed dewatering structures, as you could easily see here, and the massive sandstones with dish structures, as clearly shown and sort of identified. Then you could see the hemipelagic mudstone facies, which comprises of the massive mudstone facies and the laminated mudstone facies. So this, what we're trying to sort of infer from this facies is the fact that one, this deposition was quite rapid, and these units were deposited in a more fluid form. This could sort of explain that these diaphragms were quite active during the deposition of these sediments, hence a same depositional relationship. And so as the diaphragm grew, a lot of these units were being sort of, how they could rapidly deposited as the diaphragm grew. And as they are being deposited, they still contain a bit of cornered waters of fluids amongst them. And these fluids try to escape, giving you some of these dewatering pipes and some soft sediment structures like the dish structures that you see. Then there are debrites, which we believe represents the chaotic reflectivity units that we saw on cross sections. And this debrite could either be muddy, sandy or chalk debrides. So for just seeing the chalk debride gives us an idea that actually there are some reworked older units. So that means that actually they've been dragged up by the Merganser or say the scooter diaper. In this case, there isn't much of the chalk debride around the scooter. We tend to see more of the chalk debride around the Merganser because the Merganser was quite active and was sort of dragging up the older unit up. And as they dragged up, they were shedded down into the younger Forties sandstones that were being laid at the time. So finding imprints of this chalk debride among the Forties gave us an idea that actually there is a control and interaction with this actively growing salt diaper at the time of its deposition. And then you tend to find, well, your typical hybrid event beds where you find an interbedded, say a turbidite base capped by a muddy debrides or a hemipelagic mudstones, or you find an interbeds of turbidites, muddy debrides, hemipelagic mudstones. So here's the vertical core for shear association of the Forties fan system that I sort of logged. So in the logging, it's basically saying what we've seen in the core photos and trying to log it and sort of correlate to our gamma ray or our wildland log properties to see if these actually correlate. And you can see easily that all the blocky GR sort of represents the massive sandstones, you know, and some actually the hybrid event beds. So in this case, it's difficult to sort of pick what the hybrid event beds are or what a massive sandstone are, because within the hybrid event beds, you will actually find an interbed of massive sandstone as well. So most gammas will pick some hybrid event beds as a massive sandstones, or you will see like the gamma will show you like some sort of a heterolithic where you will find a muddy debrides, hybrid event beds. Within the hybrid event beds, a muddy debrides, a turbidites, a hemipelagic mudstones. It was difficult to sort of arrive at this interpretation, but after a very long time, I feel that's sort of the best I could get out of the data, given that trying to constrain the depths of the diaper because the wells were sidetracked and all those stuff became quite challenging. So I just sort of need to work with what I have available and trying to see if I can actually bring out certain information that will justify my interpretations. And I feel what I've done actually backed most of my interpretations of the fact that a lot of the gamma rays are actually the massive sands or the dewatering sandstones or the dish structure sandstones. And some of the unit like this would have represented your typical hybrid event beds. And most of the low GR units, high GR unit would have represented your hemipelagic mudstones as well, like we have here. So this is an example of a core that was drilled on the scooter and this from the Merganser wells. So now to conclude, do we actually, so how then do these salt diapers influence deepwater sedimentary processes? So on our RMS Amplitude Map, we highlighted the influence of the salt diaper on submarine fan system fairways, i.e. ponding and deflecting of these. We show that the top and base of the Forties fan system are characterized by distinctive bright amplitude, parallel to subparallel continuous reflectivity. And internally, this 40 shows variable reflection character. And the Forties fan exhibit variable thickness, as we've seen, that they thin towards the diaper or on the crest of the diaper and thickens away from the diapers. This actually shows that these active diapers actually influence the systems. And then we show that around the diapers, the reservoir quality becomes quite questionable, and trying to sort of properly characterize the reservoir of trying to do a proper reservoir characterization around the salt diapers become quite challenging because you have this variable facies, as we've seen on the course, where you're either having your amalgamated sandstone facies, or you're having your hybrid event beds, so you're having your hemipelagic mudstones or your debrides. And so the issue of reservoir connectivity and sort of communication becomes quite challenging and limited, and more or less require a more high-level reservoir engineering and reservoir modeling. You know, we also noticed that soft sediment structures, e.g. dewatering pipes, dish structures, loading structures, and injectites observed in the core facies would represent one, a rapid sedimentation, control on the fluid dynamics and the flow dynamics by salt diapers indicated by the deposition of hybrid event beds. Yeah, thank you.
Thank you very much. Okay, I think you can hear me, right? Yeah.
Yeah, I can.
Yeah, thanks for that. I really enjoyed your presentation. I love the integration of the well data on the seismic. I do have some questions, but let's give priority to the ones that we have in the Q&A. So there's a question from Ruairi McDonald. Are the Forties thickness relationship also observed in TVD?
In TVD. So, well, I would say yes, because I have the seismic in two-way time. So I will say yes. I would expect that even if the seismic were in true vertical depth, it's still possible, right? That it should be the same stratigraphy and geology anyway. So I don't think if the domain at which it was being sort of processed or recorded would affect what the facies would have been. So I guess yes, it should still vary whether it's in true vertical depth.
Yeah, it seems to be a real thickness change. And I guess if there's any depth imaging done in the seismic, it will still be there, right? So yeah. Makes sense. From what I can see. So we have here Brandon Getty, sorry if I don't pronounce it well. Your cross section shows wells in MD, measured depth. How does the thickness variation change when put in TST, true stratigraphic thickness? Are the wells highly deviated? Your cross section shows how. So
yeah, so I think it's been the central North Sea issue. So the wells were in fit. The wells were the measured depth in fit, and the thickness changes. So well, again, I think regardless, right? It should be the complexity of the system and the underlying structural imprints of the salt diapers and the activities of the salt diapers is such that it's more or less an obvious fact to sort of say, oh, no, if I do it this way, would I have seen a difference? Well, even if you do, you probably wouldn't see much of the difference because the fact still remains that actually the depth is so, again, like I said, imaging the diaper as well became a bit challenging. I remember having the argument with Chris about if this resolution was good enough to actually understand what the exact size and position of the diapers are. And again, going back to if the wells were really deviated, I would say yes. So one of the issues I had was I never had access to some sort of a processing report. You know, I just had like a patrol project given to me. It was just, the data itself is a subset of PGS mega survey. And what Shell gave me was just a patrol project with no processing, no report, nothing on it for me to even look what the deviation angle, what was done on the seismic and all those stuff. But from just a visual point of view and seeing what I'm seeing on seismic and even on, say, 3D window and 2D window, you can see they are highly deviated. So it's so much more that no matter how you try to zoom out to see if you could pick individual wells, it's almost impossible. You only see one top wells, but a bunch of colors clustered around one place. You know, so one of the arguments I had with that math student, my Viva, was, can I show individual wells? And I said it's not possible because I will have to zoom the data to like 1,000. I still wouldn't see one single well because they're all clustered in one place.
Yeah. So it's challenging with so much data.
Yeah, so I just believe the highly deviated, to be honest.
Okay, hope that answered the question. Let's continue with the ones we have here in the Q&A. We have one from Mike Hudek. Hi, Mike. Do you have enough data to infer the mapped distribution of any of your facies or facies? How are they distributed with respect to the diapirs?
So yeah, so at this point, I wouldn't say I have enough data, right? I probably just have about 15 wells, and even the cores. So some of the cores were really missing inside an interval of interest. So most of my judgment were sort of looking at what I've done, looking at what has been done, and trying to bring what has been done to what I am thinking to say, okay, this is what I'm thinking, and it sort of correlates what has been done, you know, and arriving at the conclusion that, yeah, this is what I am possibly seeing. You know, again, going back to the fact that I had limited data, that's a proven fact. I kept chasing Shell to see if I could get more data, more control wells to sort of say, okay, can I get this well at this location? Can I get this well at this location? Since this well seems to just being clustered around this area, then I am sort of constrained with my analysis. So I can't really extrapolate because I don't know what is happening, say 100, maybe say 10 kilometers away. I'm only forced to see what is happening around just Kuta and Meganza. I don't even know what is happening around Makar, Diapa, or PS, you know, so the limitations are there. The data are not really exhaustive enough, but most of my judgment were first based on seismic geomorphology, and so, okay, fine, this is what my geomorphology is telling me. I could see the interaction. And then on the limited course that I had, which is not even up to 1,000 meters, the core distribution that I had, up to 1,000 meters. So it's quite limited in this case, but as limited as it is we still have an idea of what we're seeing and what our judgment sort of justifies our judgment anyways. So yeah, I would say I don't think if I have enough data, but even at that, you know, what I was able to lay my hands on really gave us something that is justifiable enough to make certain interpretations and decisions on them.
Okay, thank you, Isaac. Yeah, I had a similar questions, but related to that distribution around the salt diapers. If you had tried some of the thickness maps, you know.
Yeah, so I did. Sorry, so I didn't include it here. So I did some.
Okay.
Again, that was during the Viva, and yeah, so you know, while doing the PhD, supervisors didn't really say they not need to put that. Then the examiners raised it. And then I had to go back to my folders, where are those thickness maps, and I brought them out. And yeah, it's you will see those thickness around those diapers, a more thickened 40s around those diapers area, and a more thickness trend that goes southeast. But I don't know what is happening in the PS area, so I don't know how far they continued. But then I could see those thickness, kind of a differential thickness distribution around those diapers, anyways. So those were obvious facts. Sorry, it wasn't included in the presentation.
Okay, no worries. Thank you for sharing your research. We have another question from Hussein Ali. Have you done any PaleoScan or other softwares to help showing the fairways?
Yeah, so I didn't. I tried doing geoteric. But I didn't. So because I had already worked on the Taranaki dataset, which really have your typical geomorphology features where you see the channels. I think it's not similar with the North Sea. It's a bit difficult to really see geomorphology. So I tried geoteric, and because I am even limited with the coverage of the dataset, so say if like Ben Kilham's work, more regional, you know, he could sort of track the system from the Northwest, the Nelson Forties area, Montrose area, down to Mysore delegation, down to the Pierce, and even almost the edge to the Norwegian Graben. So those were the sort of data set that will give you that sort of a conceptualized view or a more regional view of the fairways. But in my case, I'm more or less limited to just what is really the distal central graben. So, and in that sort of a location, my attribute map was only showing your typical sheet and low weight kind of structure. And going back to his PaleoScan question, yeah, Imperial College did have license, but it was Lydia. And at the point when I thought of using it, I think I've come a long way. And I don't think if PaleoScan would have added something really new to it anyway. So I just didn't bother, because if I had did geoteric and geoteric showed something, I would have wanted to do like an isoproportional slicing or other stuff using geoteric. Using PaleoScan, again, these are not your typical layer cake stratigraphy. So how would you even want to do like, say, an isoprop analysis when you know you would just be cutting through a highly deformed stratigraphy?
Yeah, and related to the attributes, Isaac. So we have a question about the RMS Amplitude Map. So maybe we can go to the slide and then we can have a look at what Righty McDonald is asking. So be easier. Okay, so the RMS Amplitude is asking, in the RMS Amplitude maps, there is brightening on the far side of the diapirs with reference to the positional direction. Why do you think this is observed?
Yeah, sorry. Does it mean on what side of the diaper?
On the far side. Yeah, I'm not sure.
Yeah. So when I started the talk, I talked about having more or less two provenance system for the Forties. The Forties they were sourced from the Garnet area directly from the west, and they were called the lateral fans, and they were Forties sourced from the northwest. That's from the Forties Wantos High area, and they're called the axial fans. So I probably have to understand what he really meant. And again, relative to our location, right? This is just a subset map. You know, we might just be here, and Forties might still be coming from here. It's still southwest, right? It might be coming from here. It's still southwest, right? So our location relative to the Central North Sea is not exhaustive enough to really say which of the fans we're looking at. But from past work and existing literature, we know that we had the Garnet. Actually, there's a guy in Manchester that worked this very feature you're seeing, which is a bit distinctive, is actually like some sort of a slide from the Garnet collapse down to the basin. So they are more pronounced. They're actually MTCs. They are more pronounced in the Maureen sandstones. Somehow, you actually would pick them at this level, but they were more pronounced on the Maureen's. You will see this huge scarp that is very typical of our mass transport complexes.
Thank you. Yeah, I'm not sure if it meant that there's brightening near the diapirs.
Okay.
Well, I don't know if you can clarify in the chat, just to make sure Isa is answering your question. So there are I just realized some other questions in the chat from Ramon Gonzalez. What is the mean deviation of the wells? Wow.
To be honest, I don't know. I don't know. I probably would have checked on Petrel, right? But I really didn't check. Yes, I don't know. So, and usually those will have been information that will come with, say, a process file. If I had the CSV and all those ASCII files, I never had those. Everything I came with like I said, I just had a Petrel project given to me with no other supporting files or documents to look at. Yeah, but okay. I knew I could check that on Petrel, but I didn't. So I wouldn't want to probably claim to do something I didn't do. I didn't, so I don't know. I didn't.
That's a difficult question, actually. So we have another comment.
Yeah.
From Kong Jing Liu. Gamma ray seems not to have good correlation with core grain size. Maybe you can go to that slide and see, what the person is referring to. Do you have any comments?
Yeah, I do, right? So to be honest, it's very tough. It took me a long time doing this, and I kept going back and forth and trying to see depth shifting, what's the depth difference, and I really couldn't have any sort of a tangible explanation to why the gamma ray wasn't really well correlating to the cause. Because I think this very point you raised was raised over and over again, even when I've gone to see the cause and all the stuff. And I probably just took the data as is and sort of interpreted as is, to be honest, because I thought of doing a depth shift, and I don't think if that would have solved the problem, given that these wells were deviated and sort of highly sidetracked. So I wouldn't tell her that, yeah, this is 100% kind of a valid point. But I feel, as perhaps flawed as it is, I will still I can still lift up some science out of it and sort of back what I'm doing on seismic anyways. But I wouldn't tell her this like an exhaustive 100% interpretation of gamma ray and core sort of interpretation. So what I just did here basically was saying, fine, I've looked at this core, and what the core was telling me is actually taken at this depth. And then I looked at this depth on the seismic, on the gamma ray, and see, fine. I picked that the day I came back from Aberdeen, and I said, fine, this core said it's from this depth to this depth. But then my understanding of, say, while and log, doesn't seem to be correlating. And I raised this with Howard, and we're trying to see why this is not really sitting together. And I didn't want to be, say, manipulated to start saying, oh, let me manipulate this data just to get what suits me. So I just feel the best thing at this point will be, fine, take it as is and see if you can interpret something out of it. And that's just what I did.
Just a comment, Isaac, on, because we see something similar in Triassic sandstones on the Irish Atlantic margin, where they have very poor, a very non-typical gamma ray response.
Yeah.
And over there, I'm not super familiar with the Forties Sandstone and where the sand is coming from, but in the Irish case, there's a lot of radioactive. There's a lot of like sort of it's coming from, I can't exactly remember the composition, but it's coming from a source rock, sort of an igneous source rock that has a lot of radiogenic particles in it, and so it gives it, much higher gamma ray values than you would expect to have in sandstone. So potentially something to look into, maybe. Yeah.
So again, I had the same sort of, either maybe the sands have been sort of feldspathic in nature, and that's sort of I thought of doing like I forgot what this analysis I wanted to do, and I sort of raised it with my supervisor if there's a need to do that, sort of do a more provenance analysis to see what are actually the composition of the source rock, of the source of the sediment, to see if they're actually quite feldspathic. In this case, having a probably high gamma content, and that would be the reason why even when the gamma is quite low, to be your typical probably different lithology, it's still within sandstones, But I never get to do the analysis. Yeah, it's probably another probably thing to look into, which was highly considered during the PhD. But again, dealing with multinationals and trying to get data set was a bit. I remember waiting for like a year to get this data. That turns out not to be completely complete, and that was why
it could be a bit like Fort Knox.
Yeah, and that was why I had to go on with the Taranaki work, because then I kept chasing. Then COVID came, and the PhD was more or less forced to come to an end because I was running out of funding. So we actually requested for more data, doing more of a geochronology analysis to see if these sandstones were actually feldspathic in nature, and that could be the reason why there's this high gamma spike, or what could be the reason. Of course, our visual inference see this sounds to be more your like the massive stands are a bit more acoustic. You could see the grains, but what are the composition? Can we really sort of justify this argument by saying, fine, based on our geochronology analysis, they contain this level of this, and that could be the reason why we're seeing the spikes in gamma or low gammas, even when the gamma is telling us, or the core is telling us this. But I never had a chance to lay myself on those supporting sort of data that would have probably proven the facts beyond what I'm seeing currently. But yeah, I think it's a point, and we actually thought of it.
Thank you, Isa, Connor, for the comments. I wanted to change the last question that I had because I think Clara has a comment, so I'll leave her to close the webinar. You mentioned ponding. You mentioned deflection and ponding.
Yeah.
So of course, I mean, you're not showing everything that you did, but I was just wondering, like, from what I can see some lateral confinement rather than, rather than ponding. So I was just wondering, because normally when we think about ponding, we think about lateral frontal confinements, kind of blocking the sediments from, you know, continuing until they get there's a spill or filling of the space and the spill. So I was just wondering if you have, I don't know, if the slide, if you can go back to the slide and show a little bit more of that ponding that you mentioned.
Yeah, Clara. So I knew
I missed it.
I think with me, I knew you were going to raise that. So it was a good thing. It was a good thing. It was a good thing you raised it. Yeah. So there was actually this contemplation of either it was actually funded, and probably that was what led Matt to say maybe it's not a typical mini business, because this the diapers were oriented along the flow fairways and more or less I would say lateral to each other. It wasn't really something really blocking the path of this the sediments, right? So if they're coming this way, they have the choice to go this way, right? They have the choice to go this way, or like you said, they might just be confined. That might be the reason why I had one of my Viva examiners saying he doesn't think if there's a mini basin, it might just be some sort of a salt saddles and just the soil interacting with the fluctuating system. And I'm beginning to give it a thought for correction purpose, thinking I did point it out in the thesis saying it's not your typical fill and spill model, which will have been your ponding kind of a scenario. So if it's not a typical fill and spill model, then that's me contradicting myself saying, fine, this might not be ponding, they might just be laterally confined, because it's not really an obstruction on the path of this. Really, it's just something flowing the same axis together. So the system just try to find a way to move out of the move away from the diaper. So yeah, deflection will be a proper word to use and sort of a lateral confinement as against using the word ponding. So I will say, yeah, thank you for that.
Okay, awesome. Thank you. Thank you for explaining. Yeah, so I don't know, Clara, are you there? You have a comment, so I'll leave you.
Yeah, I'm still here. So yeah, thank you very much, Isaac, for the presentation. Mine was just really a comment. I was just going to say that conceptualize the views of, you know, the fairways that were mentioned earlier.
Yeah.
That some of those might be available via FMB, you know, the facies map browser. So I think you could actually maybe find some information in there if that helps. But they're highly conceptualized anyway.
Okay. I'll write you after this, Clara.
Okay, no problem.
All right, thanks for that.
Great point. Well, thank you very much. I think we don't have any more questions, so we will let you go so you can finish your correction. Thank you for sharing your work. Good luck, all the best.
Thanks for the input and thanks for your time.
And nice to see you. Well, thank you, everyone.
Thanks, Isaac. Great talk. Cheers.
Thanks, Connor. Thanks.
Thank you, everyone. Have a lovely week.
You too. Bye.